Good morning, everybody. Today's lesson is on friction. We should be used to friction in the natural world. We should realize that many different types of friction occur. So far, we've talked about friction due to air resistance when things move through air or fall through air. We Now we're going to introduce the concept of friction uh, as a resistive force that opposes motion of an object. Okay, and for instance, when this sandpaper moves across the table, it will produce a force that goes against the motion. Uh, we should see another type of friction that we could talk about is going to be in liquids, which is going to be called viscosity. That has to do a lot with the motor oils and stuff like that. Where does friction come from? On a microscopic scale, a lot of times we're going to see that there's going to be a roughness between there. Sometimes, though, even with perfectly smooth surfaces, we're going to see that there will be high friction. For instance, wet glass on a flat lab table has a tremendous amount of friction due to the molecular forces that act between the water, the glass, and the table. Now here we go. Here's our formula for measuring friction right here. We can see that our force of friction will be equal to what's called the coefficient of friction. If you look right here, we can see that this uh, mu k right there, that uk is going to be what we call the Greek letter mu. If we want to go ahead and practice writing that on the screen, let's see if I can select my pen. We can see that it was not letting me select my, there we go. It's a U with a tag. U with a tag. That's the Greek letter mu. It sort of looks like an M and sort of looks like a U simultaneously right there. And then basically it's going to depend upon the force of friction depends upon a couple of different things. That coefficient of friction as well as the normal force, which is equal and opposite to the weight. If we look at different these are going to be the coefficients of friction right here for different situations right here. We can see that the larger the number is, the higher we could call it the friction rating. If we if we look at this right here, we have a situation here where we have rubber on wet concrete and rubber on dry concrete. And we can see that the number on dry concrete is going to be higher. And that's because friction acts less on the wet, or we could say that the friction value or rating for the wet tire on the ground versus the dry tire on the ground, it'll be less for the wet tire. Oh, so yesterday we took a look at a thing called the free body diagram. Let me change back to my pointer here. And the free body let me go ahead and bring it out right there. So the free body diagram shows all the forces involved. Okay, the first one that we looked at was going to be the weight. If we looked at this was the man accelerating the crate along the rough surface right there, because the weight pushes down on the ground. If we draw a picture of him real fast, I know it's hard because I'm not the best stylus artist, and he's pulling uh, this cart along the ground right there, and it's moving that way right there because because the box pushes down, the table pushes back up right there, and that push back up is going to be called the normal force. Because he is pulling it forward this way, there's going to be applied force, and because there's going to be a dragging that occurs between the box and the floor, there will also be a force of friction right there. So that's just a quick review of what we did yesterday. Which leads us to our first friction problem right here, okay? Okay, so what we have, quite simply, is we have a box that is sitting on the table right here. It has a mass of 4 kilograms right here. And we know that that's going to be the mass is 4 kilograms. And we're going to see that the coefficient of friction will be equal to 0.25. The first step in doing this problem is to change this mass into weight. So the weight is equal to mg, which is equal to 4 times 9.8 which equals 39.2. If we do, now that's the weight, so no, because we know the weight, we also know that the normal force is equal and opposite of that. It's going to be equal to 39.2 newtons. So we can then calculate the force of friction. The force of friction is equal to mu times the normal force. The mu was given as 0.25 times the normal force, which is equal and opposite of the weight, 39.2. If you give me a chance, I'll pull out the calculator. And we're going to see that we're going to bring the calculator in. If we do 0.25 times 39.2, the answer we get is the force of friction is equal to 9.8 newtons. Oops, let's just pull the tab. 9.8 newtons. Pardon me. All right, moving forward. So if we look at the next question we have right here, it says if we have a brick that's on a horizontal surface and it's sliding to the right, what are the directions of the friction force and the normal force? Well, if it's sliding to the right, then the force of friction is going to go to the left. And the normal force always goes opposite the weight, which is going to be up. So the correct response will be left up. Friction goes left, normal force goes up. Moving on. Let me try right now. Okay, I'm getting laggy, so you need to give me a second. All right, and that's actually enough for today's lesson right there. I'm also going to attach some practice problems for you to do. The only tricky part of these friction problems will be is if they give you the weight, you need to make sure that if they give you the mass, you need to convert it into weight. Another way, if they give you the mass to be able to calculate this right here, the formulas that we're going to be able to use will be force of friction is equal to mu times the normal force. Well, we should realize that normal force is the same as weight, and weight is equal to mg. So the force of friction is also equal to mu times m times g. That m times g section right there is the same as the normal force. All right, so I'm going to go ahead and stop this recording. And I wanted to, this is the first time I did it like this in a long time. So we'll see how it goes. If it's not the best thing, we'll figure it out and move forward. All right, if you have any questions, let me know. Thanks, bye.